Hello, everybody. Welcome to one more exciting session in Azure Data Engineering. In this particular session, we are going to basically learn about Azure Cosmos DB. Okay, we'll understand what is Cosmos DB, why do we need Cosmos DB, and we will do some simple hands on exercises on Cosmos. Now, to start with, Azure Cosmos DB, we can simply say it as fully managed NoSQL database. Okay, it scales automatically based on the demand. You will get a very good performance. You can expect a single digit millisecond response time. That is what, in simple terms, Azure Cosmos DB is. Okay, you can say that it is fully managed service. Azure Cosmos DB takes away all your database administration of your hands, like with automatic management of updates, patching, etc. Now, Azure Cosmos DB, it will also help you to handle capacity management with cost effective serverless and automatic scaling options that responds to the application needs to match capacity when in demand, right? Now, all that is fine, the features are fine. First of all, why do we need Cosmos DB? Now, today's applications, they require to be highly responsive and always online. Now, to achieve high performance, that means low latency and high availability instances of these applications, they need to be deployed in data centers that are close to the users. Now, if users are spread across the world, we have to still make sure this application is deployed near to the users. Now, this application needs to respond in real time to large changes in high usage hours. And they should also store ever increasing volumes of data and make this data available to users in milliseconds. That's a big challenge. Now, Azure Cosmos DB, because it is fully managed NoSQL and relational database for modern app deployment, it offers millisecond response time. It automates the scaling, instant scaling, along with the speed. Okay, those are the uses of Cosmos DB. It is a fully managed SQL database. It scales very fast and performance is very good. Now, when we say fully managed NoSQL database, what is the exact meaning of this? There are a lot of NoSQL databases like MongoDB, Gremlin, Cassandra, Table, PostgreSQL. These are the different types of NoSQL databases that are available in the market, right? Now, how Cosmos DB will help us to manage this NoSQL databases? Now, Cosmos DB provides an API for all these NoSQL databases. Okay, so by using these APIs, we can manage this NoSQL databases very easily. Now, Cosmos provides a SQL API. It provides a Gremlin API, a MongoDB API, Cassandra API, Table API, and it also provides PostgreSQL API. These are the different APIs that are provided by the Cosmos DB. With the help of these APIs, it is very, very, very easy for us to manage this particular NoSQL databases. And now it is a very important that we choose the API when we are creating a Cosmos DB. So when I'm creating a Cosmos DB, you have to mention whether you have to work with SQL API or you have to work with MongoDB API or a Postgre API or a table, Cassandra API, etc. Because once you choose an API, you cannot change that. You have to go over and create a new Cosmos DB, right? So now Azure Cosmos DB offers multiple database APIs like Cassandra, Gremlin, Table. So Gremlin is what? It's a graph database. Okay, MongoDB, Table, SQL API, Cassandra. Now, by using these APIs, you can model the real world data by using a documents, or it could be a key value pair, or it could be a graph, or it is a column family data models. Now, this APIs allows your application to treat Azure Cosmos DB as if it were various other database technologies without any overhead of the management. That is the importance of this particular APIs. Now, Azure Cosmos DB, it will also help you to use the ecosystem, tools, and the skills that you already have for data modeling and querying it for over various APIs. Now, all these APIs have these features that we discussed, like automatic scaling of storage, throughput, flexibility, performance guarantees. There is all the APIs will get these features. Okay. Now, these are the different APIs that are available, as I told you. And there's one more API apart from that you see on the screen, that is called as Postgre API. Now, let us look at the different components that are available in Azure Cosmos. It basically contains four components once we create a Azure Cosmos DB account. That is one thing called as a database account. Okay. Inside that, we can create something called as a database. And inside a database, we can create containers, and containers have items. Now, this terminology, the terminology like database, container, items will change based on the API that we are choosing. Okay. Now, let me show you those terms. Now, let us say if you're choosing a SQL API, okay, the database term will remain database, container is container, items is item. But if you're choosing a MongoDB API, now whatever we call a container, it is called as a collection. And whatever is an item, it is nothing but a document. You can say it is kind of a JSON document. Now, if it is a Gremlin API, which is basically supports a graph, right? The database term is referred to database, and the container is referred as a graph here, and the item is referred as node or edge. Now, if it is a Cassandra, the database is referred as key space, and the container is referred as table, and item in Cassandra is referred as row. And in a table, there is no database term for this. A container is called as table, and the item is called as item. Now, in when we're learning about Azure Storage Account, we learned about table storage, right? The same table storage also have an API that we can use that table storage, or we can manage the table storage by using Cosmos DB. Now, before we jump into some hands-on exercise, let us discuss one more important concept on Azure Cosmos DB called as partitions. All right. Now, there are something called as a logical partitions. Now, item in a container are divided into subsets called logical partitions. Okay. So all the data which we put inside Azure Cosmos DB are divided into something called as logical partitions. And now there's a partition key. The partition of the item is decided by partition key that is associated with the item in the container. Now, let us say if we have a JSON document for an e-commerce company, a data set have something like customer ID, product, and some like a, let's say, cost. Now, if we want to choose, we can choose a product as a partition key or a cost as a partition key. It is based on us. We can choose anything as a partition key. Now, what is the use of this partition key? It will help us to query the data faster. Okay. When we actually do some hands-on exercise, you'll understand more about it. But it is a very important when we are creating a Cosmos DB, and when we create a database, we need to choose a partition key. And we should also be very mindful when we choose a partition key, because Once you create a partition key, we cannot go back and change that. All right. And there is something called as item ID. Each item also has an item ID. This helps us to uniquely identify an item in the partition. Now, who gives this item ID? As soon as you upload an item to Azure Cosmos DB, it automatically allocates or creates an item ID for every item that is put onto the Cosmos DB. Okay. And there is something called as identification. The combination of partition key, okay, the combination of this partition key and the item id is called as identification. We can identify the items with the help of partition key and item id. Now it will help us to uniquely identify an item within a container. Okay, to uniquely identify an item in a container, we have a combination of partition key as well as item ID. Now, each logical partition can grow up to 20 GB in size. Now, there is no limit when it comes to the number of logical partitions within a container. There is literally no limit how many number of logical partitions that we can have. And the size of each partition can grow up to 20 GB in size. Now let us discuss little more about partition key. Now you should choose a property to be a partition key in which the value does not change. These are the some of the best practices. How do you choose a partition key? Okay, you should choose a property to be a partition key in which the value does not change. The property should have a wide range of possible values. Okay, now if it has a wide range of possible values, this ensures that your items get spread across multiple partitions, so all the items belong in just one partition. Okay, if the property does not have a big range of values, then it will be an issue when it comes to the query. And now lastly, once you decide on the partition key of a container, you cannot change it. Now, the only thing that you actually can do that is go ahead and create a new container with a new partition key and then copy your data from the old container onto the new container. So you cannot create any or you cannot change the partition key of a container once it is created. Now, let us understand the costing that is involved on Cosmos DB. Okay. Now, the cost of database operations is measured in terms of request units. That is called as basically RU. Now, what is a request unit? A request unit is actually a measure of CPU, IOPS, and the memory. So instead of actually charging you separately for CPU, IOPS, and memory, everything is taken as a single measure, and that's called as request unit. That is the underlying infrastructure. Okay. Now, why it is in terms of RU? Because we don't manage the underlying infrastructure like compute, memory, all that we don't manage. Everything is managed by Azure Cosmos itself. Hence, since everything is managed by the platform itself, in terms of the costing also, they have a different term, and that is known as request units. Now, request units are the same no matter which API that you choose. Either you choose a SQL API, either you choose a Cassandra, or Table API, MongoDB API, whatever API you choose, you'll be charged based on the request units. And the cost of building a single item, just as an example, as 1 kilobyte is one request unit. Now, other operations at updating or deleting items have their own measure once it comes onto the charge of request units per each operation. Actually, you can see the amount of request units that are used for that particular operation. So when we actually create a Cosmos DB, when we run a simple query, we can see how many RUs that it has consumed. Okay, that is how the costing on Cosmos DB is charged. Now let us go ahead and do a hands-on exercise. Let us create one Azure Cosmos DB and select a API. Let's create a database, put some data, and let's query that. All right, let me shift to my Azure portal for that. Now I am there on the Azure console. Now you can just simply type Azure Cosmos DB, or you see there's a Cosmos DB here. Select that. On the top, you see there's an option called as create. Select this option create. Now you see, we told that Azure Cosmos DB supports multiple APIs, right? You see Cosmos DB for NoSQL, Cosmos DB for MongoDB, Cassandra, PostgreSQL, Gremlin, and Table. So you have to choose whatever API that you want to work with. Okay, let me choose this Cosmos DB for NoSQL API. Select option create. Now select the subscription that you want to create. Choose the resource group. The subscription and resource group is mandatory for any resource that you have to create on Azure. Okay. Let me give a name to the account. I'll say demo Cosmos. Now you want the capacity either provision throughput or serverless. Okay. What is this? Let us discuss that before we go ahead and provision this. Let me shift to my presentation for that. Now, a provision throughput is basically here you can provision the number of request units upfront. You can always increment or decrement the number of request units provision. Okay. So let's say if you have used 10 RUs, provision 10 RUs, you'll be billed per hour. Okay. If you want to increase the number of RUs, you can increase. If you want to decrease, you can decrease. That is provision throughput. You can provision the throughput at a container or at a database level. The RUs can be provisioned at a container or a database level. This is one way how you can configure compute by using RUs to the Cosmos DB. Now the next way is that serverless mode. What is this? Here you don't provision any throughput. This is managed by Azure Cosmos DB only based on the load that we are getting, and you will be billed based on the RU that we consume. So we don't provision any RUs. System will automatically decide for this job it requires 100 RUs or 200 RUs. It will automatically provision and it will be charged based on the RUs that we have consumed. That is a serverless mode. Here there is no hourly charge. If you use or if you consume RUs, then only you will be charged. And we have something called as auto scaling. Now, here the RUs can automatically scale based on the demand if you configure that option called as auto scale. Now, this demand is checked both at the container and at a database level. This is basically very good for mission critical workloads because you don't need to worry about the whether the performance will be good for the configured RUs, because if it requires more RUs, it will automatically scale up. If it does not require, it will scale down. Okay, this is how you can provision RUs. Now let me switch back to my Azure console. All right, I'm back on my console. Now you see I have given subscription resource group. So this instance should also be globally unique name. It is not taking this name. I'll say demo level up app. All right, now it is taking. Now we see the capacity here, whether it should be provisioned or serverless. I will choose serverless. Okay, if I choose serverless, there is no other options, you see. Now let's say if it is provision throughput. Okay, now if you want a free tier, you can say limit total account throughput. If you want to limit, we can schedule that. If you want to uncheck, it will not limit. Okay. Let's say serverless and then review and create. This will take about 2 minutes time for the account to be created. Validation is success. I am creating the Cosmos DB now. Now you see the Cosmos resource is created. Let us select go to resource. Now you're inside Cosmos DB. Now you see it is saying create an items container, etc. etc. If you want, you can choose a Node.js, Java, Python. So basically, you should connect this with your application. Your developer can connect with that. So the data will be coming to the Cosmos DB. But as of now, let us upload the data manually. Okay. Now let's see there's an option called as Data Explorer here. Select this option called as Data Explorer. Now you see once you go to the Data Explorer, this is the page that will come up. Now I'll cross this. Let me close this. Okay. Now this screen is little tidy. It's not very tidy to work, right? So you can go to full screen mode. Open full screen. Open. So now we are there on only Azure Cosmos DB page. Let it load. Select option sign in. It asks you to give a connection string. Let's go back here. Go to keys. You'll see a connection string here. Copy this. Go back here. Paste the connection string and connect. Now you are able to connect to the Azure Cosmos account. Now what we discussed earlier, we have told that we have to create something called as a container. Select this option container. Okay. So now you can create a database inside this particular when you're creating this container. Okay. Now I will give the database name as demo database. Now we also discussed that the throughput we can give either manual or auto scale at a container level. So we can choose whether you want to give the throughput manual or auto scale. If I choose manual, it is showing 400. Auto scale, based on the request that is coming, it will automatically choose. That is the database ID. Now what is the container ID? Let's say the container ID, I will give it as e-commerce. And now comes the partition key. Now what is this partition key? This is very important because our data is going to be partitioned with the key that we are going to give. I will give the partition key as category. I will show my data in some time. Let me give the partition as category. All right. And do you want to enable analytical store? What is that? We'll see that later. Okay. Now let's go ahead and click OK. So that means we create a container ID. We created a partition with this. Okay. In a serverless, shared throughput is not available. I have unchecked that option. Select option and create. Now if you see here, there's a demo DB which is created, and inside this demo DB there's a container which is created called as e-commerce. Okay. Now let us go to these items. Do we have any items? We don't have any items here. It is empty. Okay. Let us load some items. So to load some items, let me create a simple JSON file and we'll upload some data there so that we can come here and query. So let me go to my Visual Studio Code. Okay, let me create a new file. Let me create a new file. I will create a JSON file by name orders.json. Very simple file. Okay. Now, for people who don't know what is a JSON file, it starts with a curly brackets. All right. Now, inside this curly brackets, we have to give a key value pairs. Now, let's say, what is that? Let's say order ID. Okay. Now, if we take an example of e-commerce, every order has some order ID. Now, this order can be an integer. Okay. Now, what is the next one? Next one, we have something. We have put category in our as a partition key, right? Let me put category. Okay. Now, let's say category as laptops. Okay. And let's say quantity, let's say key value pair, let's say it is 100, because there should be comma here. So now let's say this is one JSON document. Now I have, let me create couple of documents so that we can query some data there. So because there are a couple of documents, enter, 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 enter. Okay. Now let me give the order ID as 2, order ID 3 here, order ID 4 here. Okay. Order ID 5. Now let's say quantity 10, 80, 70, some random number I'm taking, 60 and 50. Okay. Now let me change these categories. Now let's say these are mobiles, tablet, laptops, tablet, let's say mobiles, and desktops, let's say CPUs. Okay, now these are the different categories that we have. Now let me repeat laptops here. Why, I'll tell you that later. Okay. All right. Now these are the different categories that we have, and these are different JSON files. Okay. Now let me add these items. Let me copy this first item. Let me go to Azure console. Now you see there's something called as a new item. Select this option, new item. Now as soon as you select an item, this is how it will come. Replace this with the item that we have created. I think I didn't copy that. Let me copy this item number 1. Let me replace this here. Let me go back to the console. I'm not able to upload. Let me do one thing. Let's say upload item here. Let me put that file. Open, upload. Okay, let's enter from here. Okay, let me copy this. Okay, let me copy this item. Okay, I'm able to copy it and click on save. As soon as we save, you see there is some metadata that is coming. Okay, this will be unique, And with the help of this metadata, we can query the data faster. Let me add a couple of more items really quick. Copy. Okay, I'm adding all these items. New item. Replace with a new item here. Save. Let me add last two items. New item. Replace this. Save. The last item. Okay, new item here. Replace. Save. Now, if we see in the database, we have all the items here. Okay. Now, let me go ahead. Let's say a new SQL query here. You see, there's a plus button. Select the new SQL query. By default, it is giving me a query. Select star from container. Okay. Let me execute the query and let's see the output. You see, we can see all the output like order ID. You can see order ID 1, order ID 1, order ID 2, order ID 3, 4. You can see all the order IDs. And here only you can see the query status. Okay. How many RUs you see here? 2.34 RUs are used for this particular query. Okay. It is showing the results. How many documents it has retrieved? It has retrieved 6 documents. Okay. And the document size is 1.36, open document count. So it is basically showing us all the statistics about the particular query that we have ran. Okay. Now let us run couple of more queries and see how it works. You know what, we are using select star from C, right? But what is our table name? It is like e-commerce, right? We can also mention that select star from e-commerce. Okay, now let me execute the query. You see the output is also same for that. Okay, this is also one way how you can run the query. Now, let us say I want to use a where clause and filter data which is only laptops, where category is laptops. Okay. Now, let us say, let me create alias, like let's say select star from e-commerce alias, let me put it as O. Okay. Now, write a where class where O dot category O dot category is equal to laptop. Okay. Let me run this query, execute the query. It is showing 0. Now I have 6. Let me put that there again. Okay, you see our category has laptops. Let me put an S there and execute the query. You see 1 of 3, that means 3 has laptops in it. Okay, laptops, laptops, and laptops. That is how we can also use a where clause. Now, in this output, if you see, now you're getting your category quantity, okay, order ID, category quantity, and also some system based values, right? I don't want to see this system based values. Okay. Then instead of select star, let us put the column names that we want. Let's say O dot order ID, comma O dot category, comma O dot quantity. Okay, let me run this query. You see now, I see only these three particular values: order ID, category, and quantity. Okay, that is how also we can write queries in Cosmos DB. Not only this, we can also do group by some lot of other functions. Okay, let us say I want to see the sum. I want to group by the categories and I want to see the total quantities that are ordered. Okay, let us see how to write that query. Okay, I will say category sum sum of sum of quantity. We want to sum the quantity, right? Sum of quantity. Let me give an alias here as we don't have that column, right? So as quantity from e-commerce group by O dot category. Okay. Now it should give me the number of quantity it has sold for each category. Execute the query. Now you see desktops total 80, mobile 70, tablet 60, laptops 110. Okay. So this is also how we can write queries on a group by statements in Cosmos DB. Now let us say these are very simple JSON files. We are able to query them very fast or very easily. Now let's say there are some complex JSON files also, like objects within the objects. What do you mean by objects within the objects? Let's say this is one object, right? Let me correct the spelling error here. Okay. Now we can have objects within the objects. Let's say I also have a customer name here. Let's say customer. Now inside this customer name, I can have another JSON document or an object inside an object. Here I have customer ID. Okay. Customer ID is, let's say, um, 45. Okay. And customer name, customer name, let's say some random name. Okay. Now let's see how to query this kind of files. Okay. Let me copy paste and create couple of more files. That's okay. 4 is enough. I will delete rest of them. Okay, let me make changes to this. First one is fine. Second one, customer ID, let's say is 50. Customer name is all right. Third one, my customer ID is 67. Name is, okay, customer ID here is 68 and name is, all right. So let me copy this. Let me go to my Cosmos console. Let me delete all the files which are there here. I can select simply an item here, and as soon as I select an item, you'll have a delete option. Select delete. I'm deleting all the items. Okay, all the items are deleted. One more item is there. Let me delete this as well. Okay, now all the items are deleted. Let me add new items, which has an object inside an object. New item. You see, an object inside an object. Save. Let me add all these items here. Now, after this, we will see how to run queries for the objects inside our objects. Two more records. Let me add this. New item. Save. Let me copy the last item here. New item. And save. Let me go to new SQL query. Now let us write a simple statement here. Select order ID O dot category quantity from e-commerce O where O dot category is equal to laptops. Okay. Now let us execute this query. Now you'll see category is equal to laptops, quantity is equal to 50, category is equal to laptops, quantity is equal to 50. You are getting all this information here. Our order ID is missing in this. Why our order ID is missing? Let me go to items. Okay, we have the column as order ID. Execute the query. You see, now I have order ID, category, quantity. All right. Now, if we look into these items here, let me go here. Let's say, uh, let me show you. Select. Okay, let me execute this query. Now we have customer id and customer name also, right? Okay, let us use this customer tag also in our query. Let's see the output. Let's go here. Let me add o dot custom. Okay, and let me execute this query. Now you're getting customer id and customer name. Okay, but it is coming again as a json file, as an object here inside the customer. Again there's a json document is coming here. If we just want the customer name, because since this customer name is a property inside a customer, all that we can do is that just put a dot here and type in customer name and execute this query. You see now, order ID, category, quantity, and customer name. Okay, that is how you can work with JSON files which are having objects in objects. Now we looked how to work with simple JSON files. We looked into how to work with files which are there in one object in another object. Now let us see how to work with JSON arrays. Okay. Now in one JSON file, in one JSON array there can be multiple JSON files. Let me show you that file first, and I'll explain you how to work with that. Let me go here. Now I have created another file called as customers.json. Okay. Now let's say in this is particularly one JSON document. Now let's say if I'm a customer for any e-commerce, if I'm ordering multiple items, how it will be stored? Now my customer ID, customer name, customer city, and we have ordered laptops, mobiles, and iPad. This is the different representation of data from the customer point of view. Okay. Now here let's choose the customer city as a partition key. Okay. Now once we choose the customer city as a partition key, let us understand how actually a partition will work. Now I have three JSON documents here: customer ID 30, customer ID 32, customer ID 30. Okay. Now for this, let me create a new container and then let me load this particular data. Let me switch to my Azure console. Okay. You see there's an option called as new container. Select a new container. Okay. Inside demo DB, I'm creating this new container. I'm giving the name as, let's say, array. Okay. Here, the partition key. What is the partition key? As I told you, we'll use the customer city as a partition key. Okay. So there is basically we have to choose what should be the partition key and all. Okay. Customer city is the partition key and click on OK. Now you see there is a new container arrays created. Let me go to items, a new item. Let me copy paste the items here. Let me choose this. This is item 1, save. Let me go to a new item. Copy paste, save. This is the last item that we have. Let me copy this. I mean, basically these are JSON documents. Okay, new item. Let me copy this, save. Okay, we have these three items now. Let me go to a new query, execute query. Let's see, these are all the results that we got. Customer ID, customer name, customer city, orders. You see, orders is a array where a multiple JSON documents are there in it. Now let us say I want to see only this orders part. Okay, only the things that is there in this particular array. All that we can do is that we can simply use c dot orders. Okay, and let me execute the query. Now you see, I can only use the I can only see the orders of the first document. Okay, orders of the second one. Okay, we can see only the orders which are there in a part of an array. Now let us say I want to select only this quantity, okay, from this orders array. How we can do that? Now let's say very simple. Select we can just give it as o dot quantity from o in array, or table name is array, right? Array dot orders. Okay, we're given the table name as array. So o in array dot orders. Let's execute this. There is an error in the syntax. Now let's write this again. Let's say, okay, let me go here, right click, new SQL query. Okay, execute this. Okay, it's working fine. Now let's say select c dot quantity, okay, from c in c dot orders. Okay, we have orders, right? Let me run this. Now you see, we are only able to see all the quantities. Okay, that is how you can actually query the data which are inside a array. Okay, now let us understand little bit about the partition. So we have used partitions. One data set we used partition as the category. Another data set we used partition as the city name. Now let's see what actually happens when we use partition, how the data is segregated. Let me take you guys to my presentation. Now let us say this is our data set which has four JSON documents. Now we have choose the category as our partition key. Now we have category as laptop, category as desktop, mobiles, desktop, and category as laptop again, right? Now, as in when we create a category, now what happens? The no these two categories, the first one and last one is same, right? Laptops. Now, both this will go into one partition. Now, mobiles will go into another partition, desktop will go into another partition. Now, as and when we run a query, if it is based on the category you want to see something related to laptops, your query will run only on this particular partition. If you want to query some data related to desktop, your query will run only on this particular partition. So that is how the performance will be very good on Cosmos DB. All right. So I hope you guys have enjoyed this session. So let me recap what we have done till now. We understood, I introduced you guys to Azure Cosmos DB. We understood what are partitions in Azure Cosmos DB. We understood how the costing is done in Azure Cosmos. We created a Azure Cosmos DB database, and we created a container. We uploaded data, and we worked with different types of JSON files. That is what we have looked into this particular session. I will see you guys in the next session. You guys have a good time. Take care.